This material is made available to you by or on behalf of the University of Melbourne under Section 113P of the Copyright Act 1968. It may be subject to copyright. For more information, visit the University Copyright website.
Very nice presentation. So next speaker of this afternoon is Professor Chris Vale. Professor Chris Vale is Director, Quantum Technology Future Science Platform at CSIRO. And I'll just set up his presentation. So he'll be delivering a presentation on quantum technologies research program at CSIRO. So Chris, over to you.
Oops. Broken the microphone already. That's a good start. Okay. How's that for sound? Yep. All right. Thanks, Lisman. It's a real pleasure to be here, and it's a pleasure for CSIRO to be a sponsor of the QTML conference. It's really great to see so many people come together for this, and even to come along for a session of industry talks after I'm sure you've been already trying to absorb a whole lot of science talks as well. So today what I'll do is give you a little bit of an overview of some of the quantum work that we do at CSIRO, or as we pronounce it in the quantum field, CSIRO. And a special mention has to go to Lloyd Hollenberg, who sat right in the audience, for pointing out this pronunciation, and in fact showing that at CSIRO we cover all of quantum, from pure states with the wave function through to mixed states with the density matrix. So thanks, Lloyd. You'll get sick of me making that joke every time. I took a photo. Yeah, okay. All right, so a few words about CSIRO. So we're Australia's national science agency. So you've probably heard about CSIRO, but I just want to give you a few, just kind of set the scene for you for what the organisation is and what our role is in the country, and how we hopefully contribute to a better nation. So we're actually one of the world's largest multidisciplinary science and technology organisations. We do research mostly in the applied space, but through from quite basic through to quite applied. We have roughly 6,000 people employed at the organisation across 50 sites, primarily in Australia. So one of the biggest sites is down in Clayton at Monash, which is or across the road from Monash Uni, which is about 20 kilometres from here. We also, I guess, act as a custodian of various pieces of national or significant national research infrastructure. So things like the SKA, and also the ship, the investigator that goes off and studies the oceans, and in particularly the Southern Ocean. And again, someone very clever, or cleverer than me, has done a calculation that we deliver up to $10 billion of benefit for the national economy. So that's through things like supporting startups and various industries that have spun out of CSIRO, or various companies that have spun out of CSIRO. So a few words about what we aim to do as an organisation. So we really try and perform the science that addresses some of the nation's greatest challenges. And so CSIRO's thought about these challenges, or the areas that we work in. So that includes health and wellbeing, food security, Secure Australia, etc., etc. You can read those. Some of the inventions that we're well known for are the Wi-Fi, which was developed at CSIRO. AeroGuard, so any international visitors here, I strongly recommend you buy yourself a can of AeroGuard so that you can spray and keep the mozzies off, particularly around dusk if you're outside. Polymer banknotes, and the Hendra vaccine for horses, so to protect horses. Okay, so where we actually sit, and what is our role in the kind of innovation ecosystem. So one of the big things we want to do at CSIRO is see some of the sort of basic research that happens at universities evolve and translate across something of a valley of death, which is kind of this valley between these two hills here. So if we imagine research moving along this scale from the basic to the applied to the development or prototype development through to production scale, CSIRO is trying to situate itself right in this middle point here. So trying to cross this valley of death. So help take some of the basic research where we often work with universities. So for example, we're involved in some of the work that Harry mentioned in his presentation, all the way through to governments, NGOs, and eventually companies as well. So this, I hope, gives people a feel for where CSIRO sits, and you can see it, oh, sorry, go back. You can see it spans quite a broad part of this spectrum. Okay, so my job at CSIRO is to run a program called the Quantum Technologies Future Science Platform. And so I want to tell you just a few words about that. So at CSIRO, we currently have around 150 people working on either quantum or quantum adjacent areas. And a large fraction of those people work in the Future Science Platform. So the Future Science Platform is essentially built on three pillars. So the idea with the idea that we had is that as a national science organisation, we really wanted to develop the capabilities from the sort of personnel and expertise level through to some of the ideas and technologies that will sort of progress into the use cases of quantum. So we have at the base a pillar of sort of not really blue sky science in the sense that we talk about it, but what we call Horizon 3 science, where we think the applications are on that sort of 5 to 10 year timescale. So we start off with a pillar of science. We then focus on engagement, so raising awareness both within the organisation, within CSIRO, but also in other areas across the organisation. And then finally, connecting externally, so with universities, government, defence, etc. So really trying to work with some of who we believe will be the first users of quantum technologies. So that's a bit of an overview of the program, but really we're trying to establish the capability that's going to support and build the next generation of the quantum industry. So this slide is really a summary slide of the various quantum research areas that we have at CSIRO. So I'll talk a little bit about some of these. So we have quite a strong effort in quantum sensing. So for a long time, actually, this was spearheaded by our current national chief scientist, Kathy Foley, developing superconducting quantum devices or superconducting quantum sensors to measure very small changes in magnetic fields. These devices have found application now in detecting mineral deposits underground. We also have some of the work that Harry referred to is now also taking place at CSIRO. So Liam Hall leads an effort there developing diamond or NV diamond-based quantum sensors for biotech applications. So things like measuring iron content in blood, but also portable NMR, miniature NMR type systems. And we have activities based on sort of using quantum assured time transfer as part of PNT, so inertial navigation or geolocating. So that's on the sensing and devices side. And some of these activities are growing into other areas. So, for example, RF and terahertz detection as well using superconductors. And we have a kind of a good devices and packaging facility at CSIRO. We also work quite a bit in the sort of quantum software space. So basically developing algorithms and applications for quantum computers. Quantum machine learning, which I'm sure there's been plenty of representation here. So Usman is really leading that effort at CSIRO. Another effort that Usman's working on is developing a full stack quantum software platform. So really enabling or trying to make quantum computers accessible not only to quantum physicists but also to users that'll be accessing quantum computers at a higher level. And we have work on post-quantum cryptography and integrating that with QKD systems to make sort of complete quantum-safe communication systems. Some of the emerging areas that we're developing, so we have a program on quantum readiness, which is really involving social scientists as well, and sort of the preparation for the adoption of quantum technologies and how prepared different industries are and how prepared they need to be. We're also working on or looking at the possibility of establishing quantum computing test beds. So the idea with quantum computing being at the sort of nascent stage that it's at, that often researchers and users of quantum computers want to actually be able to get in under the hood and understand the real hardware implementation of the codes they're writing and try and optimise it or tailor it based to specific hardware platforms that they're using. We have a quite new effort on looking at quantum effects in energy storage, so some sort of proof of concept demonstrations where quantum effects or collective quantum effects can enhance energy storage rates in two-level systems initially, and as well as developing hardware for quantum communication, so single photon sources, etc., and other parts of the quantum supply chain. Okay, so I'm just going to put up this picture from the National Quantum Strategy, showing that actually we do work in a large area of the sort of key topics that were identified as being relevant for Australia in the National Quantum Strategy. We're either working directly on those areas or how these technologies can be enhanced. Here's a snapshot of the various project leaders within the Quantum Technologies FSP, and you'll see Usman here, but yeah, we have also Manolo Per, who's working on quantum chemistry type calculations and where NISQ devices can actually do something useful, or what's required, how many shots are required, etc., before you get experimentally accurate results. And Liam's efforts in quantum sensing, and yeah, Justine's leading the work in responsible innovation. So maybe in the interest of time, I might wrap up there, but yeah, happy to talk further about any of those topics or take any questions. Thank you.
Thank you, Chris. Second talk also right on time, so we're really good tracking on time. So the next talk is